Hey everybody, amprepairguy.com, 203-892-4119. Also harbackelectronics.com. Please like, share, and subscribe. I've been so busy here at the shop. I had an amp to repair earlier and I put that up on here, the repair video. I had some other stuff to do. I have 3 amps that have to go out tomorrow. I have 2 Harbach orders that just came in recently, like 30 minutes ago, so I have to fill those in the morning. I have more amps to work on, so I had a sliver of time to work on this tonight. I'm getting excited. I'm almost done with the RF deck, and then I can pull the power supply section in here. Just have to put the plate choke in, do a few other little things. So, I'm going to explain what I did tonight. First off, this started off as... I need to plug all these holes, I just noticed. So, this started off as a 2 kilowatt RF generator. The only thing I'm reusing is the meters, the protection board, and the wiring. So no one can say it's just a simple conversion. I think I showed one of the other ones in the other room, so I'll show one when this is all done. You can see this has been a lot of work. So I've had some help with things here and there. Jim V, 7RF, another engineer guy's giving me some advice. This is a first for me. This multi-band setup right here. I'm trying to cram it all into this cabinet, but I think it's coming out pretty good. So luckily I have the service manual for this. So the wiring and all that, the protection board, it's all in there. Makes it a lot easier. So this had an 8877 in it. So as you know, 8877s have a really fragile grid. So it had grid overload and plate overload. And a really good protection circuit. Really fast. Opto isolator. So I'm going to try to explain it here for you. So the way it was set up is you flip the breaker on the back of it and blower would turn on, and as long as the blower's on and the pressure interlock for the blower sensed that it was on, filament transformer would get power, and then after the filament was on for 3 minutes or however long it was, then, and no faults are present, you could press the reset button to turn it on. So the way it would turn on is, when it comes to turn on as in start to produce output, there was a relay here. I had another video showing the old relay. The relay would close and it would short out a resistor over here, one of these resistors that's acting like a cutoff resistor, and had a Zener diode with biasing. So if there was a fault, it would open that relay up, shut the plate down, shut the driver off, and put the tube in a cutoff. And then you'd have to wait the 3 minutes all over again. It was like a nightmare. So I had to take the relay off, add another contact. So now I'm retaining the grid and plate overload. Now it's adjustable by these 2 adjustments. A guy here in Connecticut who taught me a little bit back in the day gave me some advice on that. I don't know if it's going to work or not, but we will find out. So I can set them, and once it's set, forget. So trips, it will end up opening the ground side of the bias, the new bias relay, the input vacuum relay, and the output vacuum relays that are on the other side. So it's just the ground side, so it's opening the ground side. The positive side is the side that's switched. The supply will be in the bottom cabinet, trying to save on weight. This thing's already heavy enough. And it'll have that speed up circuit like the 6-meter amp, and it'll be inhibited until, same cycle, have a pressure interlock, basically the same as the other amp. So I had to change the shunt resistor for the plate current meter. The old one was too small. That's the proper one in there now. Standby, it has the standby operate switch that opens the ground side to all 3 relays. so it won't key. And the reset button is still wired as it was stock, so if it trips, but there's no 3-minute delay. Oh man, I am tired. So I added some ferrite beads. I literally have over 150,000 of them, so it might not be needed, but I figured why not. So I have these feed through caps. So these are the bias leads. The original way it was biased, it had a Zener diode connected to these two leads, and it was referenced back to the cathode of the tube. Obviously this is triode, doesn't have a separate cathode from the filament, so instead it's connected to the center tap of the filament transformer. So I'm going to have the diodes over here, so they're blasted by air. 6 amp diodes, proper amount. One lead will go this feed through here, the other lead will connect this side of the resistor, and then when this relay engages, the normally open contact will short these resistors out, which will bias the tube on. So if the protection trips, it'll bias it off, unkey the relays, and also bias it off over here. So that'll actually should operate, first, because that controls the other relays, so it should be lightning fast. So that's about it. If you need an amplifier repaired, feel free to give me a call. I'm doing as best I can over here. Can't wait till this is producing power. This is for the B negative. I'll explain that. It goes through the floor. There'll be a terminal strip where the B negative and B positive come through an armored cable. So that's that. And I might, this was the wire used to shut the driver down. I'm thinking about reconnecting it to the Amphenol connection and actually setting it to do something else. I'm not sure yet. So again, thanks for watching, and I'm tired. Have a good night. Catch y'all later. 73. Point something out. These two leads right here go to the meter that reads power output. I'm not sure if I'm going to keep it a power output meter or not. And there's a multimeter that shows the filament voltage. The filament sense leads actually go over here and connect after these chokes. One of them's after the 100 ohm resistor. Just in case it were to somehow short, wouldn't have to worry about the full current capability being available at the protection board. But that's not going to happen. But that's about it. So, almost there. Okay, I'm going to post this, then I'm going to bed because I get up early. So, 73.